Hi, eighth graders. If you're watching this video, you probably already have this document open, and it shows initially some of the final results from all of our oat seed growth. Our tallest overall was from Monica and Miss Dressler's experimental group. We had, man, a seed length of 275 millimeters. A few that came close, but none as close as Monica's. Well done. I am still cranking out some numbers for the individual with the highest average growth from all 6 of your seeds. So check back on here later. We do have the class, though, that had the highest overall. That was also Miss Dressler's group. Maybe Monica, maybe your seed growth pushed that average up over the top. Overall, with our Thursday, Friday cohorts, that was my group at 203.61 millimeters. And then Miss Dressler's group, man, something was going on in your classroom. So we'll have to think about maybe what were the conditions like in each of the different rooms to maybe promote higher growth versus other rooms. Anyway, big task for today. I want you to look onto the data for the next page here, because you're going to create the graph that you see in your oat seed packets. And I had you just isolate this page right here. This is the only one that I wanted you to keep. If you're if you're watching this video, you're probably just a Monday, Tuesday folk. So you are going to use this data right here to make a double line graph. Double line graph, meaning there are going to be 2 lines on this graph. Okay, not just one. It's not a bar graph, line graph. And so one of your lines is going to be tap water data, which is right here. The other line is going to be experimental data. You might have been wondering, what is that experimental solution? It was plant foods, fertilizer. So you're going to find out, was that solution more effective in growing your seeds taller? Now, the purpose of this lab was to kind of see what's science skills you still got from previous years. So I'm not going to give you tons of information on how to create this graph. I want you to run with some of the pieces that I give you. Now, one of the tricky parts is always, all right, what's the x-axis label? What's the y-axis label? So x is always horizontal, y is always vertical. And your y, thinking independent, dependent variable, which one goes where? I always find it easier to remember whatever we are measuring. So we are measuring seed length, okay, in millimeters. Whatever we actively measured goes on the y-axis. So seed length is up here. Make sure you label it properly. And then whatever our time was, so we were measuring seed length over a course of time. Time is always on our x-axis. Okay, we're not measuring time. So our time was in measurement days. Okay, and we had 7 different measurement periods over the course of this experiment. Okay, so you're going to have 7 days spread across the x-axis. And then you need to, because you're thinking of scale, how do I fit you? Because you want to look at what was our tallest seed length or seed average over both of these groups. So we look at this, so we have to make sure that we fit in 211 on this graph. So I want you to try to spread out the data as much as possible. So you shouldn't be ending your data like right here. So like 200 shouldn't be right here. So think about, how can I get 211, maybe a little bit over, because it's never great to have like the last data point right up at the top. So try to have your last data point like up here towards the top somewhere. I'm going to leave it up to you to try to spread this data out appropriately. I think you can do it. I want to see what skills you still have. So make sure we'll have 0 down here, and the 200 range should be up here. If you somehow, I don't know, went by 10s, 20s, maybe you ended up with like 220 up here. I'm not going to tell you exactly what to do. So after you have your scale, you have your x and y axis plotted, you can begin to plot your data points. Now, since you have 2 different lines, and I know maybe you don't have 2 different colors at home, what you can do with the tap water points is fill in the data points with a small circle. And then with the experimental line, do these little tiny triangles. That's what it states right here, little tiny triangles. And you want to tell me that in the legend. Okay, indicate small circles are tap water points, small triangles are experimental points. When you connect the dots or the triangles, use a ruler or a straight edge, please. I know you're going to do that already. Okay, you're highly detailed students. Please, no hand-drawn lines. because these may be intersecting and they may be close. So sloppy, wavy lines isn't going to help us. Okay. If you have specific questions, feel free, shoot me an email. I am totally confident in your ability to create this graph. I think the most tricky thing will be to create the scale. Again, if you're 220 or whatever it ends up being is like right here, rethink the scale. I want you to extend this up here. Now, let's say if your last point ends up being right here, that's fine. Or right here, that's okay. But it shouldn't be, down here. Definitely if you went by like 50, 100, 150, 200, 250, no. Spread this graph out. And also your 7 should be down in this range here. Okay. So that's what I want you to do for today. Create the graph. Use also, if you still need to finish this up tomorrow, you need to ask me a question, finish it up for tomorrow. I'm going to have you guys turn this in on Monday. Okay? Hope you have a wonderful day. And if you happen to be watching this video and you're actually a Thursday, Friday cohort, you're using this data. Okay, if you're Thursday, Friday, using this data. The only difference is your numbers are slightly less on the highest average, and we only had 6 measurement days. Okay, have a great day.